Hi everybody, I'm Kyle Houchins. I'm Tech and a Trainer for McNeil, and today I wanted to talk about a feature that is kind of an unsung little superhero that hides way down here under the points menu called Move UVN, and I'm going to just bring this guy up. It's a really kind of an awesomely cool tool that doesn't get a whole lot of love because a whole lot of people don't know about it. And what it does is it allows you to have a little slider interface in order to be able to modify points when you're dealing with surfaces, and to some extent there's a little bit of functionality for sub-D, but I'm not going to really focus too much on that today. I want to just talk about the basic usage of it, and then if you want to play with it on sub-D, you can play with that on your own time. What I want to talk about today is basically what this does is if we have a surface and we look at this thing, and you can see, let me go to wireframe, you can see that it's a little bit of a mess, right? You can see that it's got a loop in here, and you can see if we shade it, it's got creases and it's got folds and all sorts of stuff, right? And that is not a super ideal situation because self-intersecting surfaces like this cause all sorts of problems with data transfer and printing and all sorts of stuff like that, because if we turn the normals on, you can see that the normals go wee around in a circle, right? And we don't want that because the normals are pointing in the wrong direction at the wrong places and all that kind of stuff, right? So we don't want this kind of situation, not to mention the fact that you know, there's certain circumstances that we'll look at in the next example, where having a self-intersecting surface will actually cause a trim to fail and all sorts of stuff like that. And if you've watched the pipe trim video, this is particularly important if you're using pipe trims, because pipes often self-intersect if the pipe diameter is too big versus the rail that you're trying to run it across. And the next example I have will actually show that. But let's look at the basics of what this does. And if I turn the points on and I select these points, right? And I'm not going to mess around with this point, and I'm not going to mess around with this point because these are the G0 points. And so if we had a surface that we were trying to work on, we wouldn't want to disturb these points because we wouldn't want to tear, get rid of my history here. We wouldn't want to tear, history's like, no, don't leave me. We wouldn't want to tear apart from that, right? So if I mess with any of these points, I'm going to create a tear in the surface, and then obviously it won't join. So I'm going to leave this entire row alone, and I'm going to leave this entire row alone. So we never want to really select that. And it would be cool if we could just select a row of points and lock them, but we can't do that just yet. So what I'm going to do is I'm going to grab all of these points inside, and I'm just going to do it on one row now so you can see what's going on. And if I smooth this in the V direction, you can see what happens is they actually untie. And so I can actually go down this entire row, and if I do this in wireframe, it's a little easier to see. You can see what a mess these points are, right? So I'm just going to grab these guys, and I'm going to just untie these in the V. And I'm just going to do this until that mess is straightened out. Oop, not the view. I want to do it in the V. And you can see how that loop is now gone, which is what we wanted to get rid of. And then it gets a little more complicated on one like this, because you can see that these are crossed, and this is crossed, and this is crossed. So let's maybe pick at this a little bit. So I'm going to start with these three, and I'm going to just smooth these out. I'm going to untie those, and then I'm going to grab, this one's way out of shape. Let's undo and grab all of those. That guy's way out of shape. And you can see that that all starts to come back into line. And this is getting better, but this is still a mess. So let's grab all of this. And I did it in a couple of stages just so I can kind of keep an eye on what's happening here. But you can see what's happening, right? They're uncrossing and they're untying. And I can get back to the point where if I shade this, you can see that that loop is gone, and this is now a detail that does what I want it to do, as opposed to, you know, essentially a bad surface that would cause problems down the line for, you know, data transfer and prototyping and all sorts of stuff like that. So that's one way to use it. The other thing that I want to point out is there's scale in here, right? So if I grab these guys, let's grab a bunch of them, and I have my scale set to 1, it works like this, right? If I set this to 10, this slider works a lot faster, and if I set it to 0.1, now it starts to really slow down. So the edits, you can see I have to drag the slider much farther in order to get the same amount of edit. And if I come down here, it really starts to slow down. So this allows you really fine-tuning of stuff. Now, so that's the smoothing aspect of it, which you can use to untie things. Then there's the aspect of Move UVN, which is really helpful if you're trying to dial in a form and you don't want to do this just with point editing. And down here, I'm going to set my scale to about 0.1. And normal, you can see, actually let me crank that up. Normal, you can see it goes directly in or out of the surface. So I can add sculpture details, I can remove sculpture details, I can fine tune, and depending on, you know, what my scale is set up, I get really fine adjustments of what's going on with this surface. So say for instance I wanted to add a little overhang detail here, I can move this normal and I can start pulling that detail out a little bit, and then I can move it in the V, or I can move it in the U, depends on what you want to go side to side or up and down the surface. And then if I've gone a little too far, I can certainly go back and just smooth this in the V, and you can see that these all start to kind of come back together. And so what this tool does is it gives you a lot of control over sculpting things. And one of the beautiful things that we know about NURBS is you can define the boundaries with curves, and you can define the inside with curves and all that kind of stuff, and that's great. But if you really want to get a hold of this stuff and you really want to start making things that are art instead of CAD models, at some point you're going to get into the points here. And so this tool allows you to really dial in kind of exactly what you want to happen. And you can pick one point and smooth it between the other two, or you can do a whole row at a time. If we were to grab this whole thing, and smooth that out on a more global perspective, right? We can actually just flatten it all the way back out if we wanted to. So the cool thing is if we look at these points, right? So we were only smoothing in the V, but if you look at the control polygon here, the dotted line that connects these, that's considered the control polygon. You typically want, if you're trying to do smooth surfaces, or, you know, clean transitions and clean highlights and stuff like that, and I'm not talking about adding a detail to a part like a fin or something like that, where we would grab this thing and just, you know, go like that, right? You know, we're not talking about doing something like that. I'm talking about, like, typically speaking, you want your control polygon to flow smoothly depending on, you know, your situation. This can be a really useful tool to kind of help sort that, and I can smooth in the U as well, and so I can actually start straightening these things out a little bit and cleaning them up. Right, see that? And these two I probably want to smooth in the V. Pull them apart a little bit. So we can get through here and start doing things like this, where we say, okay, the control polygon has a big jog in it right here. So let's straighten that out. And then the control polygon has a big jog in it going this way. So let's straighten that out. And we can start to kind of pull this together. And I'm saying at this point that the design intent is for this surface to be smoother as opposed to having these big waves in it, right? And so we can come in here and adjust this stuff until we start getting a better flow in our UVs, right? So I can pull this guy back in line because we don't want to touch this ones on the edge, right? So we're leaving those alone. In this case, this is flat, so if I wanted to, I could come up here and I could actually move this one, sorry, in the U like that, and it would just be sliding down the edge. But I would want to make sure and check this later when I joined it that that hadn't pulled that out of shape. All right, so as we're doing this smooth in the U, smooth in the V, we can use this to untie things. So let's look at a different example. And if we go to the top view, we can see that this is the typical result of a pipe trim. Let's just assume that this was an edge of a surface, and we ran a pipe trim around it because for whatever reason the fillet was going to fail or whatever. And you can see exactly why the fillet would have failed, because the radius of this change is bigger than the radius of the actual curve that it's trying to follow. And so what it does is it creates these little self-intersections. And if we were trying to do this with a pipe trim, this wouldn't work because we wouldn't be able to trim with this because it would make a weird little thing here. So let's turn the points on for this guy. And it's a poly surface, so let's explode it. Always good to look at the command line, figure out what's going on with your world. And I'm going to just use lasso, which is a tool that also a lot of people don't know exists in Rhino. And we're going to select these guys. I'm going to bring up Move UVN, and we're going to smooth in the U, and you can just see all of those guys untie. Okay, now we want to keep an eye on our design intent here, because we want to make sure that these shapes that are making up the trim are actually doing what we want them to do. And so in this case, I may actually come in here and clean up this entire corner. I might just smooth this out a little bit, and I might just smooth this out a little bit as well. And what that does is now this gives me a clean trim curve. If there was a surface going this way and a surface going this way, this would give me a clean trim curve. Now let's look at a more extreme example. And I'm going to go a little farther down the road here, and I'm going to use lasso to grab all of this junk in here. And I'm just going to give this a yank, and you can see that it just unties itself. Every time I show this in a class, there's this like silent realization that, oh my god, all that garbage I've been making for years, I could have fixed it. And to be fair, I made a lot of garbage over the years, and so this is one of the tools that I have used to salvage and turn that trash into treasure. There we go. And save hours of time just straightening out a few things and then getting on with your life, as opposed to trying to rebuild it and make it quote right. We can argue all day long about whether or not this is quote right or quote wrong. I guess I personally don't really care, unless you're doing Class A modeling where there are very strict requirements for what the surfaces have to do and how the points have to align and all that kind of stuff. 90% of product design, you just need to get there. And this actually is a technique that can be used for Class A modeling because it gives you that fine control over the points. but most of us are going to use this, you know, to get out of the office at 5. And I'm okay with that. You know, sometimes the right answer is to just be done. So let's look at one more example. And in this case, we'll turn the points on for this guy. And the trick is to be able to read your control polygon. And in this case, if we look at just this row, we can say that that's okay. You know, it's going in, out, in, out, in, out, in, out. And nothing's messed up or crossed or screwed up. And then we get to the next one. And you can see how from the side view, it looks okay. It's going in, out, in, out, in, out. But from this view, you can see that this row has become very distorted in the fact that it's come out like this. So let's grab this guy and let's just bring him back a little bit into line. And I'm going to just drag him over here like this. And that looks, let's make sure I went in the right direction. So that brings him a little bit back over into line, right? But I've lost my form, which then I come up here to the end and I put him back to where he needs to go, which was right out here in the first place. And doing this in shaded view obviously helps a lot, and I can't stand modeling in colors, so I'm just gonna do that. And so you can see that now I can start moving this guy around to really put it exactly where I want. So I'm going to use smoothing to kind of get it to where I want it to be, and then I'm going to use the moves, you know, to get it better. And I can, you know, I can do it the opposite way. I can use moves to put it back in place, and then I can use smoothing, you know, whatever works for your particular situation. But it allows you to be able to kind of interactively go in and straighten this stuff out. And we can look at this row, and this row is fairly straight, and it doesn't look like there's anything too crazy going on in here. Looks like, oops, cell U, wrong direction, cell V, come on. Oh, there we go. Third time's a charm. See, I look stupid, so you don't have to. Alright, so in this case, we look at this row, and if we go to wireframe and back up a little bit, we can say that, alright, this actually looks pretty okay. Maybe these two we want to take a look at. And it doesn't look like they're crossed, so I'm not going to sweat that too much because they're pretty much lined up in that direction. I don't see any like crazy left-rights going on here. In this row, there is though. So if we grab this row and do cell V, and again, I try to leave the position, the G0 points alone, so that we don't mess up the edge, assuming that there's something else attached to it. In this case, there isn't, so it doesn't really matter. But I try to keep that stuff, you know, I try to keep the edits and stuff internally. So let's smooth this in the V, and you can see that that whole row lines up. Now we have to check and see what that did. And in this case, I'm pretty okay with everything that it did. Maybe we want to emphasize some details here, and then we'll just do that with move in, you know, move in the N. But down here we've got a mess, right? This guy right here needs to be straightened out. This point, and this point, we're going to smooth those out. See how that just unties? Look at that. And let's put it back. And then we can adjust the forms, either using gumball, you know, we don't have to always use this. Gumball's sometimes faster. But between those two tools, Now we've taken this thing that was kind of a mess and we straightened it out to the point where, you know, we could mirror this. We could match surf, even tangent if we wanted to. And we wouldn't have wanted to do this with this, you know, with this mess on the edge, because we would have made a real mess here. And so, you know, maybe there's a shift boot or some kind of grommet cover or whatever, or maybe it's just a badly designed surface that we're using for a demo. that's okay too. So anyway, that's kind of what I wanted to show you about this tool. I first of all just wanted to make you aware of the fact that it's here. The second of all, I wanted to talk a little bit about what's going on. There is a couple of different modes here. The move along tangent versus move along control polygon, you know, you can experiment with those two. I never use along extensions, so actually I can't really explain what it does because I never use it, and I'm not going to lie to you about that. And then you know, UV symmetry, you can mess around with those as well. I usually use this in a very basic way, and I usually use it just to clean up stuff. You know, most of the time what I'm using it for is in the pipe trim example where I'm untying pipes, because I do a lot of pipe trimming. I was doing a mold making project and there was thousands and thousands of molds that I had to pipe trim the mold into the base plate, and the pipes were always tying up, and this was just a superhero in that particular project. So it's here, check it out, hope you like it. I'm Kyle Houchins, technical trainer for McNeil. Go make great stuff. Thanks. Bye.